This next part has to do with slope. Now, I know that we're in chapter 6, but we need to do a quick little lesson on slope before we get into chapter 6. So slope has to do with like how steep a line is, okay? So linear functions, that means functions that are lines, right? Linear means lines, and function means just like an x and y function. It's going to be a graph. They can be classified by their steepness, how steep they are, or we call it their slope, the slope of the line. So just like positive and negative correlation, you can also think about a positive or negative slope. So a positive slope or a negative slope. Now for people that are right-handed, this makes it easy. Put your right hand in the air. In other words, something's going up like that. If it's going up to the right, that's positive. A positive slope goes up to the right. A negative slope means it goes down to the right. So down to the right. Now, we always read a graph from left to right because we read math and we read English and French and most languages from left to right. Now, I think Mandarin is one where they read it vertically, but we're not going to do that. So we read all of our graphs from left to right. So you could say it's going down to the right. You could also say it's going up to the left if you're going backwards. Right? It's the same idea. So what kind of number is neither? Well, what's not positive and it's not negative? So it's in between. Well, 0. Right? A slope of 0 means a graph has 0 steepness. In other words, it's a horizontal line like this. It has 0 steepness, or in other words, we say it has a 0 slope, right? So this is a horizontal line, horizontal. I always think about it as slope kind of means like skiing. If you have 0 slope, in other words, you're going out cross-country skiing, you're in the middle of a farmer's field somewhere, there is 0, it's completely flat. Now the opposite of that is straight up and down, a vertical line. Now the opposite of 0 is like infinity. It's infinitely big. In other words, it's infinitely steep. You're going skiing and you went off the cliff and boom, you're going straight down. So this is infinity, or in other words, they say it's undefined. It's an undefined slope. It's so big, it's infinitely steep. This is a vertical line. Vertical. So slopes are either positive or negative, or they could be 0 or they could be vertical. So you would say this has an infinite steepness, or in other words, it has an infinite slope. It's usually they say it's undefined in the back of the book. So the slope of a line is really defined to be the ratio of the vertical change to horizontal change. Or that is, it's the rise over the run. I always explain it like, imagine you're going upstairs. First, you're going to rise up, and then you're going to put your foot out. So you don't put your foot forward first. No. First off, you lift up your foot, and then you go over, right? And then you step forward. You have to rise up first. So rise over run. So the vertical change, and then you do the horizontal change. Now, this may have units. It may have unit if it is a rate of change. What? Like how fast is something changing? Like, for example, kilometers per hour. That's a rate of change. It's your speed, right? Yeah. So, for example, speed or velocity might be like 80 kilometers per 1 hour. Kilometers per hour, those are my units. Now, if they don't give you units, then it's just 80 over 1. It's whatever that is. Now, you can write it as 80 over 1. You can also just write it as 80. Now, you could write it as 160 over 2, but like we know we always simplify that down to 80 over 1. Okay, so we can read a slope right off a graph if you just look at from point to point to point. So line A is, well, hang on, this one's line A. The rise over the run. Well, the rise, you could go from this point to this point, for example, is going up 2 and it's going left and right 0. So it's 2 divided by, that's why. Or you could say it's 4 over 0. 2 divided by 0, when you divide by 0 on your calculator, it'll say error. So this is infinity. Or you could say it's undefined. Undefined. In other words, it's so incredibly steep, it's undefined. It's not defined. It's just not at all. Okay, B is this one. Now notice the line is going up to the left, or in other words, it's going down to the right. So I know it's going to be negative. So what's the rise over the run? I could start here and go to here, or I could go here and backwards. Doesn't really matter as long as I use a negative. Let's start here. And I'm going to go up 1, 2, 3, and then over 2. So it's 3 over 2. That's it. The slope is negative 3 over 2. And it's okay to leave it as a fraction. Don't turn it into 1.5. No, because think about it. This is your rise. This is your run. When you go up 3, you go over 2. See? Up 3 over 2. Up 3 over 2. Up 3 over 2. So I could have just continued on that pattern. That's in fact how we're going to draw our lines. We're going to figure out what the slope is, and we'll do up 3 and over 2. Now I could have also gone 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, right? To get from point to point. But you know that 6 over 4 will also simplify into 3 over 2 as long as it's a negative slope. Okay, now you'll notice, let me show you an easy mistake that some people make. Don't make this mistake. They're going to go from this point to this point. They might say it's 1, 2, 3, 4, 1, 2, 3. So that's 4 over 3. No, 4 over 3 is wrong. I know it's not 4 over 3. Think of it, it's the distance. I'm starting here, so I'm not counting 1. Now I count 1, 2, 3. So I've gone up 3, and now I'm counting the distance. 1, 2. So it's 3 over 2 in that way. So don't count the initial point. It's how far have I gone from there. So up 3 over 2. What about line C, this last one? I know it's positive. And if I started here, I could go here, or I could even go to here, or let's see. What's the rise? What's the run? It's going up 1 over 2. Up 1 over 2. It's just like a staircase. I could also go down 1 over 2, down 1 over 2, as long as if I'm going backwards. But this is a positive slope because it's going up to the right, and it's positive 1/2. There we go. Positive 1 over 2. Positive 1/2. That's my slope. Now I could turn it into 0.5, but don't. It's better to have it as rise over run. Fractions are your friends when it comes to graphing. Okay, now there's actually a slope formula. M for monter, I think. Is that what it is en français? Means to climb, means to go up. This was done by a Frenchman named René Descartes. He was the one who came up with these ideas for graphing. So he called it M for monter. That means the slope. Because, you know, S would not be a good one to use. My S's look like 5s. Okay, so M is the rise over the run. Now, here's a little secret that you're not going to hear anywhere else. Oh, maybe you will. The rise, in physics notation, we call this the delta y. So it's how much did the y change. And the run is the left and right. It's the x. It's the delta x. So in other words, it's how much did the y change? How much did the x change? We'll always do the rise first. And if you actually had x and y points from 10 to 4, right? There's y and there's y. I'm going to call this one y1 and y2. From 10 to 4, it changed what? It changed 14? No. You do the difference. I'm going to go 10 minus 4. Or I could also go 4 minus 10. Either one, doesn't really matter. And then the x's, I'm going to call this one x1. I'm going to call this one x2. So this is point number 1. This is point number 2. 2 different points. The change in the x from 8 to 4, that change is 8 minus 4. So it's going to be the difference. You subtract it. So there's an actual little formula we can use. y2 minus y1, it's the change in the y's. That's what delta y means. Divided by x2 minus x1. So it's the change in the x's. Notice I did 2 minus 1. I like doing 2 minus 1. I do the second one minus the first one. You could do it the other way around. 1 minus 2, 1 minus 2, as long as they match up. But I can't switch one of these without changing. Okay, well, let's try and use this formula. What's the slope? So the slope is going to be y2 minus y1 all over x2 minus x1. Now, y2 is the second y value. In other words, it's 4. What's y1? In other words, the first y value. It's 10. Okay, and then the difference in the x's. x2 minus x1. So if I started with this one, I have to start with this one for the x's too. So it's going to be 4 minus 8. 4 minus 8. Now, you know what? It might have been easier to do it the other way around because look, I got negatives. But look what I get. I get negative 6 over negative 4. And I know that those negatives cancel. It gives me positive 3 over 2. There's my slope. So I could have drawn this on a graph, or I can also use this quick little formula. y2 minus y1, so delta y, divide by delta x. Okay, let's try this one. It says line L has a slope of negative 2/3, so I know it's going to be going up to the left. And, well, you could also say it goes down to the right. And it goes through the point 5,1. So how do I graph the point 5,1? Left and right first. It always goes x and then my y. So 1, 2, 3, 4, 5, and the y value is 1. 1, right there. So it goes through that point. And it says this thing has a slope of negative 2/3. So it's not going to look like that. No. It's going to be going up this way. So this thing's going to go up 2 over 3. Up 2 over 3. Yeah, because that would have been going 4 over 6. I could keep going. Up 2 over 3. If you do a few points, you're going to recognize I could have gone down 2 and over 3, but I'm also going off the graph. Now let's keep it here. Okay, so there's my line. I'm going to put arrows on the end because this thing goes on forever. It keeps going on forever. It never stops. So that's what the lines do. So give 2 other points. Okay, so this is the point we started with. What's this point here? It could be the point over 2 up 3. So it could be 2, 3. What about this one? I'm going to go to this one way over here. 1, 2, 3, 4. So it's 4 to the left. 1, 2, 3, 4, 5, 6, 7. So it could be -4 and 7. Now I could use any point in between here too, right? But these are not dead on. Try and go for the dead on points. Like I could estimate this one. It looks like it's 1, 2, 3, and it's 6.1, 6.2. It's not, it's an estimate, right? You're better off going for those dead on points. Okay, so here are some of the key ideas that we need to remember for slopes. Positive slopes go up to the right. Negative slopes go down to the right. A slope of 0 means it's a completely horizontal line, 0 slope. But if it's undefined, in other words, it's infinitely steep, it's a straight up and down line, vertical line. So think about skiing, 0 slope, whoa, infinite slope. I'm going straight down. I fell off the cliff. So the slope is the rise over the run. That's what it's defined to be. And yes, we do have a formula. We could do it's y2 minus y1 divided by x2 minus x1. Now here's the secret. If you wanted to, you could also do this. y1 minus y2 divided by x1 minus x2, as long as they match up. See, these match up, these match up. You could do it either way. Most people use this one. This is usually the one you're going to see. And it's really delta y divided by delta x. It's your change in your y values and the change in the x values. And it really gives you the steepness of the line. Alrighty, so page 258, this is where we're going to find these questions, and here's a few to practice on. Good luck.